One, sourcing is under discussion and changes because of the world map of today. So if 80-90% was made in China before, we see clear signs, very clear signs, that more proportion will go to Europe and also North America. And this is not based on one OEM. This is based on our understanding of 5, 6, 7 different OEMs in telecom. So this is very important. The second thing is that out of the 5, 6 OEMs we're talking to, everyone is launching new products 2026. Hello, welcome to Goldcasting Podcast. Today we are in a state of mind of celebrating a little bit because we are going to make a podcast about applications up for grabs, meaning business that you can catch pretty decently quick. And we now see proof that we are actually on the right track. And this is based on the podcast we did like 1 year ago. So seems that things are holding true. So stay tuned, stay with us for 20-25 minutes, and you'll get a full picture of 3 very exciting application areas where we see actually RFQs, nominations coming your way. So stay tuned. But before we get into this, how did we get into a situation where 2 guys in a podcast are trying to help you and your colleagues find a new business? What actually happens? I think there's a place for us short history lessons here, there, Fabian. Could you carry out the work with this one?
Sure, I can do that. I can become a history teacher for a few minutes. So, as price pressure is always something that was around in the automotive industry. And many, especially Western European foundry, thought that price pressure by going for higher volumes, higher automatizations, and then large volumes of castings. And with that, they were quite successful for a while, but there was a trend there that even you had to have a minimum 100,000 pieces a year, otherwise foundries will not talk to you. And it was more volume, more volume, more volume, more volume. And now what we saw at Corona and now in the sales crisis, the volumes are not there anymore. So you have these highly automated systems, really expensive, and no castings going through them. So if a massive price pressure, and if you put it now on a global scale, if you have a lower volume and a massive price pressure, energy costs are higher, and also people are getting more expensive to employ. And a side note on that, the price point on these castings is now so low that even if the energy would be free, you're not competitive in Western Europe.
Due to labor.
Yeah. Due to labor and also due to the missing volumes. And having these expensive automated systems that you have a deductible to pay every month. And that's something that counts down on your P&L system that you have to pay for these things.
I think the lies also, if you look at the competition, especially from Asia, if you look at the overhead cost of running a foundry, we have more costs for following the rules and regulations. We need always a couple of guys. Yeah, massively. And those, I don't know, 15-25% units that to be put on every casting is maybe half if you go, I would say, eastern of Turkey or something. Anyway.
Yeah. Especially if you compare it, for example, for a German foundry, it's a roughly 10% of the employees have some reporting to do for some government agencies or whatever. And for 250 people foundry, that's 8 people full-time doing that if you add up all the partial works, and that's quite a lot. And then also it comes now to, if you're just producing the 27th iteration of a shock tower, there's no innovation. You can buy that thing from India, Vietnam, China without any issues. That's a commodity now. And if you're in a commodity business in a high expensive country, you have a bad time. For that, you need to do something different, and that's what we want to do. We want to show you applications that not everybody can do, that takes you with innovation into a whole new chapter for your foundry. So, Staffan, would you like to tease the first one?
Yeah, carbon dioxide systems. Ladies and gentlemen, A year ago, we said that this is going to be a big thing. The basic of it is that you have governmental rule from the European community, the F-gas ban. F-gas ban means that we cannot use the same coolant media in the air conditioning system, basically. So going from the R134B that we have today in our cars, we are probably looking at systems based on carbon dioxide. A couple of things here now. Carbon dioxide is challenging the design department very much. The pressures are much higher. You go from 15 bars to 120 bars of working pressure.
Even up to 180 bar.
Yeah. Sorry. Yeah, we see some projects here. So that's a thing. But the thing is also it's 3 times more efficient. And why is this important? Well, has nothing to do about global warming. It has to do with the battery thermal management system. That sometimes you need to warm up your battery and sometimes you need to cool it down. So it's a good thing to have an oversized air condition in an electrical vehicle because of the driver, but also the battery. So where are we in the market? Well, not to name drop too much and not to violate any NDAs, I would say the numbers of projects are increasing. The number of parts per system is increasing. So before everybody was looking at the pump itself, now we see valve bodies, we see conjunction pieces, we see manifolds. And that is good news. Now people start to realize they must have a system in place. Because if they don't have a system, the car maker, they cannot get a type approval of a new vehicle from 1st of January 2026. All right? So there's a harsh point there. Now, there are not that many vehicles that are planned to be type approved in 2026, unfortunately for me, but 2027. So you can feel in the project meetings nowadays that there's a little bit more of a, how should I put, stress might be a, yeah, let's call it stress. They're more stressed, basically. Because these systems, these castings has to be made with different alloys, casting system, sometimes different technologies. You know, I work with Rheocasting, so guess if I see them. And I mean, just for reference, I think our small firm has now built tool number 11 with customers. There are machines being sold. This is going on. But the scale up is yet to come. So, ladies and gentlemen, here's some opportunity for you.
Definitely also to add to that, from a design point of view, they are the most worst casting you can have in high pressure die casting. High wall thickness, you have to have massive leak tightness, that even if you do the perfect high pressure die casting and you do an impregnation, that is not enough for CO2, as you have to test it also with 180 bar of helium. And it just leaks through like water through paper. That doesn't hold true. And with Rheocasting, you get that thing done.
Yeah, I agree to all that. But the funny thing is that every project we start, we when we are involved, I guess there are a lot of projects where we're not involved. We get this porosity specification on the drawing. And every time I need to explain to people that never mind that porosity spec, because what you have is that sometimes you have castings with 0.005% of voids from the CT scan. It's still leaky. You can have those who are 0.1% voids that are non-leaky. It has to do more with metal meetings and interior stuff than it has to do with porosity. Then, of course, if you have more porosity, you get a leaky part, no question about it. But this is challenging the quality department, the design department, the casters, everybody through the line.
Yeah. Even if you have the most high-tech CT system, it doesn't have the resolution to see what's happening in the grain boundary between the grains. And the only way to do it is produce the part in casting, do the heat treatment, do the machining, and then test it. Yeah. That's the only way, and you need that quick feedback loop to adjust your production.
Which is transferring a little bit the whole industry sector, because it's nowadays it's built up by a lot of casters doing the as cast. Machining is done with a tier 1, guess who, and then the complete system is delivered to the OEM. But here comes the thing. The designs are in verifications now as we speak. The scale up is starting this autumn. So if you're remotely connected to some of these companies, start to do your marketing, start to invite yourself, start to be there for getting at least RFQ. Because if the final verifications are done, let's say a year from now, the scale up is somewhere around end 2026. That might sound long for you, but I mean, it's 18 months ahead, and time is actually running out for this scale up of the business. And one has to realize that there are 5 parts per vehicle. So the volumes are great.
It's not just that it's 5 parts per vehicle, it's also that the same parts are used in several series of the same OEM or even in different OEMs. And so you get something started on a small scale, and then it's minimum 100,000 to 250,000 pieces per year. That's the starting point. So it's very close to what you're already doing with the high volumes. And the second thing is, you don't need a gigacasting machine for that. Your 600, 800,000 ton machine that you have standing around without any work gets another 20 years of lifetime with that and gets you a margin.
I know. The problem in this world is, I mean, every industry has a naked ladle that everybody's looking at, right? And a naked ladle in our industry is, of course, gigacastings. And this is so remotely from gigacasting as you can imagine. We're speaking about multiple lines, high volumes, small die casting machines. It's not sexy at all, right? But
No.
Here is where you find the gold. I would say one of them.
That's one of the systems. So we already mentioned there are several things, and we need a good climate system for all the cooling. So I think we can jump to the next topic, which is thermal management.
Yes, I love thermal management. in my car, you know, I have a very dirty car going to Germany next week. I have a heat sink of some 35 kilograms of shot weight, which is a world masterclass. So, dear listener, take a look at LinkedIn somewhere around Thursday next week, and you'll see a picture of this one because it's impressive. But I promise to show it first time at the Gigacasting conference in Kassel on Wednesday. So I'll try to keep my promise.
Yeah, so it's a complexity level of a gigacasting on a smaller machine, but with around the same shot weight. So
around the same.
Really cool piece.
But why is this important? Well, dear listener, if you're running a foundry, you're looking for business, this is a spot that we pointed at for a year ago, and we were talking about 5G and stuff. We're going to expand this discussion a little bit, because what has happened? Well, first of all, the big guys in 5G, meaning the producers, the OEMs, are not only needing more thermal conductivity, they're doing 2 things more, which is very interesting for you, dear listener. One, sourcing is under discussion and changes because of the world map of today. So if 80-90% was made in China before, we see clear signs, very clear signs, that more proportion will go to Europe and also North America. And this is not based on one OEM. This is based on our understanding of 5, 6, 7 different OEMs in telecom. So this is very important. The second thing is that out of the 5, 6 OEMs we're talking to, everyone is launching new products 2026. You heard me right. And this comes from the nature of telecom, that you are selling what is not yet designed, and then you have to design something with a higher bit rate or better functionality for self-driving cars. So 5G is actually working parallel with self-driving cars.
I have to jump in to translate it a bit for every foundry used to automotive stuff. So what they're actually doing is their focus is on the circuit board, and the casting is a consequence out of that. So it's this way later in the design process. As for a car, you want to have the body structure first and then build around it. In that case, it's the other way around, and the casting is just a consequence. So every time you see, oh, we have an issue in our circuit board, you get a new casting design. And that's why also, if you're thinking about a 3-year lead time, which is normal in automotive, and you call your telecom OEMs like, hey, we can do that something in the future, and said, future, sure. After summer, we would like to start the series. And that's normal. You have 3 months to buy the tool after you get the confirmation, And then you have one trial, and the second trial will also already be the SOP for the series production, and you start digitally. So day one sees the highest volume, because as sooner you get your antennas out in the field, the more likely is that you sell more antennas. So
Yeah, there's
totally
a rule
different
of thumb.
business.
There's a rule of thumb that SOP is the same time from nomination of the tool, kicking off the tool. That lead time is the same as the lead time from the first casting, first out of tool, to start a serial production. So if you have 12 weeks of your tool, you have got 10, 12 weeks creating the prototype, adjusting the tool, getting the parts for approval. The approval is done, and then you push start of production. Now, we spoke about telecom here, right? The third nice thing around it is that it seems that 5G is finally starting to roll out, right? Which goes parallel with self-driving cars and all that, yada, yada, yada. But here comes the interesting thing. If I work 25% telecom on my working days, I work at least 20% with other thermal management projects. So half my day is thermal management. What is the meaning of this? Well, first of all, you have new system coming out. So we see more sub-telecom, if I might call it that is filling gaps, and the numbers are not bad. We see more and more heat sinks coming out because miniaturization, more LED. The power load on new LED system is actually pretty aggressive when you light them up. So just this week, I've seen 3 different heat sinks that are non-telecom. What are they have in common? Well, they want to have high thermal conductivity, and they're not happy with the regular alloys that people are using. So here's a big thing. All these are non-automotive. All these have the same thing. They are fast to production start. So if you have, again, 600, 800, 1,000 ton, 1,200 ton machines, this is an expanding market for you. And we said this a year ago, and now we see the proof of it. People are getting nominated with this.
They get nominated very quickly. And we all can be very sure that there is not an LED heatsink mega casting. It will stay as small as possible, and people want to get it smaller. And the smaller you go, the more difficult it is to get the heat away. And typical high pressure die casting alloy, they are limited to 160 watts per meter Kelvin. If you go down the silicon content, then the castability goes to the drain in high pressure die casting. In Rheocasting, on the other side, the silicon content doesn't define the castability. So an ALSE2 is as castable as an ALSE7. And with an ALSE2, there are less elements that cause a disturbance of the lattice, and therefore you get a very good thermal management. And that between 160 and 190 watts per meter Kelvin doesn't sound big of a difference. If you talk about a 5G antenna, that's about 20% more range. And if you have to spread the system through a whole country, imagine the cost of getting 20% more antennas. That's a massive cost benefit.
Yeah, but the thing is, if you look at the 226 A380 ADC12, the heat conductivity is actually 120 watts per meter Kelvin. If you go Rheocasting, you get 180, 190. Yep. So it's actually 50%
I was comparing
more.
The 160 to the best thermal management alloys in high pressure die casting.
But they're hardly castable with those fins that people are asking for. So then you have another bullshit processes like, milling off material to save weight. Because another thing is that you need to save weight when you are actually mounting things on a mast. Anyway, so let's leave the telecom and conclude the other thing, that I'm sitting here and saying that almost the same time I'm spending in telecom, which is a big area for me, I spent on other cooling system, and those cooling systems are for example, lighting on ships and stuff, and stadium lightnings and things like it. And these are growing because if you take this modern world, we need more and more light because we have more and more sensors out there. And this leads me to the next thing. If you're an automotive guy, pay attention, because what are the automotive guys looking at right now? Well, heat sinks. Have you heard about that, Fabian?
Oh, yeah. They call them sensor boxes or whatever. And it's basically like a computer centralized, and all of the connections to all the other control boxes go in there. And it puts out, like every other computer, a lot of thermal load. And it has to go somewhere. It goes into a water cooling system, and it's friction steel welded. But still, you have to go through the aluminium, and the processor capabilities just depend on the heat conductivity of the aluminium you use. And therefore, heat conductivity is the key thing. And if you get up to these high levels and you have a weldable thing that doesn't corrode, you're perfectly done.
So you got 3 applications in a car. You have the electronic box that there Fabian is talking about. You have the water cooling system for the power electronics of controlling the engine, actually. And then you have the
And you
third
can
one.
expand that also to all the thermal management for battery systems.
Yes.
They have to be tempered as well. And you have to have a good thermal conductivity as it goes through the battery cells. And there's a long way to that. And that's also a great application for these type of alloys.
Yeah, but we should be clear to our viewers. The one that we see strongest in automotive is the e-box right now. The others are more talking and more PowerPoint and more simulations on that level. But the e-boxes are actually being tested right now. So that is an upcoming market.
But still, in any automotive application, you really also need to start to market these things, that you can have an alloy with 190 watts per meter Kelvin, and you're not stuck with 120 or 150 in the best case. You have something better here. And that's a big impact. Also, if you can use 100% post-consumer scrap alloy, and that's something, at least on the first point, that most OEMs will jump on at the moment.
Yeah, that is so interesting. Leading us to the next thing about sustainable casting. Now you're in for a ride. We're going to talk a lot about this because I'm sitting in Sweden. Sweden is pretty much Greta, being very sustainable. But there are 2 industries that stick out when it comes to actually paying for sustainable solutions. One is Telecom, which has the massive volumes. The second one is medical equipment. And it goes like this, that these companies are more sensitive to the share price of the companies. And many retirement funds are saying that if we are going to invest in a company, we demand it to have a true and clear sustainability strategy that is being executed. So you have the Paris Agreement, and then you have something called scientific-based targets. So you can go in the scientific-based target and look at your customer. If you take Ericsson, for example, it says that, 2035, we're zero emission from our products, right? Long discussion. So these companies are more forward-leaning when it comes to using, for example, recycled material. So if you take the Rheocasting, for example, that was developed by a certain company, and Ericsson in this case, that is 100% recycled. It produces something like 0.36 kilograms of carbon dioxide per kilogram of alloy, compared to what you get in Asia, which is 20 kilos. So you see the difference. They are forward-leaning. Medical guys as well. And it has gone so long now also that operators and hospitals are requiring A, sustainable solutions, and B, paying a couple of percentages extra on the top level of the product. That's not happening in automotive.
No, and especially you need that, as I will give you a quick summary of the German high-pressure die casting conference. Several OEMs presented their plan for the future to become CO2 neutral. And sustainability becomes a hard fact, like mechanical properties. You have to have an alloy with a certain CO2 footprint or below that, and you have to use a certain amount of post-consumer scrap. And that's a hard fact. If you don't fulfill that, any purchaser will see your offer. So it's coming to automotive. And if you want to get to a CO2-free environment, there's also more things that, for example, melting with non-gas burners is about 40% more expensive. So you need additional margins to fund that, as usually automotive is the last price counts. And let's see if the technical departments that set these requirements have talked to purchasing about that melting sustainable will cost money.
Yeah. But let's boil this down to business opportunity. Here comes the hard fact. Besides all this blah, blah, blah about sustainability, we have the CBAM, which is the taxation of imported carbon dioxide starting 10 months from now. No, it's March. Yeah, 10 months. Okay. 300 days from now, we have a new tax to take care of. Who could benefit from this? And then I would say like this: if you are exporting components into Europe, you should listen up. Because first of all, you're probably sitting in a land with a low-cost country. Labor and other things are actually cheaper. So you have this price advantage. But when you start to get a 5 or 8% taxation for your product, all of a sudden you have the same price tag as someone inside the European community. This is bad news. But there's another thing. In many countries I'm working with, there is a lack of understanding of the scrap market, on how to do smelting and investment in solar panels and so forth. And that means that if you do your homework, which has nothing to do about your casting process or foundry technology, you actually stick out and you are the sustainable alternative for the purchasers, but you're still in a low-cost country. So if you have your solar panels, you have done your homework, you're not perfect, but you say, hey, I'm here. In 3 years, I will be here. And then in 5 years, the plan is to be here. That is good enough. And you are a winner. So here's your USP if you're an exporter to Europe. Especially if you're using primaries. Then it's
And especially the important is that you have your plan laid out. As all the OEMs, Telecom wants or medical wants to have it now, but especially if you're delivering to automotive, it's 2035, 2039. So you have a bit of time to start now, but to get to zero. And then you need several steps in between. Just picking the lowest hanging fruits every time to get to your target.
Yeah, but I have learned the hard way because I've been working this pretty much. It takes time, for example, to start the sourcing of high level scrap to a country where your scrap market is not that developed. You have to take leadership in this and work with your smelters and your scrap dealers and things. Because I think at the end of the day, what people would do when the car companies especially, they would say, but our competition, they're making so dirty cars. And this is important for many people when they're buying a car. They don't want to buy that car that is wasting the planet. I mean, look at Tesla, for example. How things could go. Everybody loved Tesla in Sweden. Then Elon Musk became a politician. And yesterday I saw 3 bumper stickers. I bought this car before Elon Musk started to be... Okay, that is how quick it goes. So people are, I think that example will show itself several times in the future.
Let's wait for the first environmental scandal that you see some cars are cheating with buying some certificates from somewhere that is not even existing. And then these fall out of favor and every car brand needs their sales.
Yeah. And if you look at it, everybody's complaining about Chinese companies starting in Europe. But I think it will be a great turnaround because now they are inside European Union. They have to pay the social bills and behave pretty much like everybody else. That will lead to some changes and the price will equalize more on certain levels. And then this will become a factor. But we're speaking about way far, 3, 4, 5 years from now. What is important for you, dear customer, now is... if you're exporting to Europe, you can be a winner if you have control of your planning for being a sustainable foundry. That is the key.
But also, when you mention the Chinese OEMs coming to Europe, they're also coming to North America. And not their whole supply chain will start on day one with them.
No.
So that's also a great business opportunity, getting in contact with them. As they are producing a lot of cars. And if you look around on the streets, you already see a lot of Chinese cars.
Yeah, but one should be careful because final words, final minutes of this podcast. But I hear so much now because we have a new guy in the White House, and some people are saying that the car industry in North America will go bankrupt before Christmas, and some say this is the great chance. We haven't seen the effects of things, but 2 quick changes in the world trade has never been good. So the question is, when we're publishing this a few weeks from recording now, a lot of things probably has happened again. But what's true and what is stable is that the CBAM Europe, that we can count on, will be the same level when we publish this in April.
let's see when we put that podcast episode out. But yeah, many opportunities, they are not on the portals. So it's something where you actually need to spend work and not just go to the portal and download it. You have to present yourself, you have to market yourself, and we have several episodes produced about how to market, how to listen, and also how to access telecom applications. And please, before you do anything, listen to these podcasts or watch them and get a better understanding what you're getting into, because you need to do something now.
It's not rocket science, so good hunting, ladies and gentlemen.
Yeah. No, it's not rocket science, but it's not going the same way as it did for the last 25 years.
But the irony is that some of it is actually rocket science for the satellite systems. But but you don't need to design the rocket. You need to find a guy who's actually buying the components.
And you're not producing the part that goes into the space. You're producing the receiver on Earth.
You can stay on the globe. So, ladies and gentlemen, thank you for listening. And it's we love this theme. If you have any questions, reach out to us. Send an email or text us or find us at Eurogas or something and have a cup of coffee and talk to us for real. Because the solutions are not that complicated. They're not that far-fetched. It's not rocket science again, even parts of it is. And then you will probably be successful. But again, hunt in non-automotive. That's my tip.
And one commercial break from my side. If you need support in developing these markets, send me a message and happy to help you to get into these applications.
Perfect. See you around in live or in the podcast. Don't forget to subscribe, and we're happy that you have been listening. Thank you very much and good hunting.
Happy hunting and bye.
Bye. Sayonara.